Hello everyone, my name is Arman Sedana and I'm the CEO and founder of Nexus Security. This is the top 100 interesting bugs part 2, and if you're watching this course first, try taking the part 1 because that was on a beginner's level. This course is something to open up your mindset, and I again say I absolutely own no rights of these reports. I am not the original founder of these bugs. These are curated by the list of hackers. I found that interesting, so I'm just breaking down on the technical aspects. I have nothing to do with those reports. They might be true, they might not be true, but my job is to just break these reports into technical aspects so you understand them better. And if you like the course, just don't forget to give a 5 star, as you love all my courses. There's a new course coming for the burp suit professional certification, the burp suit practitioner certification. It's going to be a long course, around 13-14 hours, and hope you like this course. It's short and crisp, just sharing you the details of what you should follow, different techniques of what you should be using. No bullshit, pure content. Hope you love it. Thank you. All right, everyone, so now we're gonna learn about the top interesting bugs, and the first on this list is stored accesses to privilege escalation. To understand this particular thing, I believe you have a basic background about how XSS works and what's privilege escalation. For those who don't have a background, let me explain how this thing works. Is that stored XSS is something that goes to the database and then it's executed. Privilege escalation matters to that if you are a user B, you can escalate your privileges either horizontally or vertically. Both is termed as privilege escalation. This one is known as a horizontal privilege escalation, and this one is known as the vertical privilege escalation. So was this bug all around? That if we go into the exploit chain of this vulnerability, so suppose you are an employee, you are on a website in which you are acting as an employee, then you found a stored XSS. Using that stored XSS, you got the cookies of the admin or your manager, which has a higher privilege than you. You did the privilege escalation, which resulted in an account takeover, right? You took over the account of that manager. You gained even more high privileges, access to sensitive data, and all company data is leaked. How it worked was, there is a financial program on HackerOne that allows you to do this. Admin and manager can create loans. Loans means for financial help by the people, right? So admin and manager can create loans, and manager invites the employees to finalize the loan process. So to understand this particular thing, there are two roles in that. When you are a pen tester, you need to understand these roles things very clearly. So there are two roles. First thing is the admin role, the second thing is an employee role. Obvious, its name suggests admin has a high privilege, employee has a low privilege, right? Now employee can only access the loan that you are invited to. Manager can have access to multiple loans, but the employee has the access to only the loan which they are invited to. So in the loan, there was a field known as purchase description, where which is vulnerable to a stored XSS. You can use pretty much any payload that depends upon to that particular company. We are not going much into the detail, we are just following the ideology how we find bugs. So in the purchase description, you have this particular payload which says image source on alert error. So it loads an image. If on error, it would pop up an alert. So that's a XSS, right? Employee injects this XSS payload into the loan application. Then they invite the manager. So what employee does is it injects an XSS in some input field, then invites the admin or the manager to review it. When the admin or the manager would open this page in which XSS is stored, this XSS would send the information back to the hacker with the cookies of an admin. Once you have the cookies of an admin, you took over the entire account, because cookies is something that authenticates us into that particular account. So once the manager opens that particular thing, so that's a taker of admin account. And once you are an admin, you can see the information of the clients, because we studied that admin had loan creates loan. So loan has the PII, personally identifiable information of the clients. So that results in a mass client data leakage. So this was the first bug which I personally liked, because it is a clear example of how we change the vulnerabilities, right? Moving on to the second bug. The second one, this was one of my favorite findings, that the team collects that the Nexus security team collects all these resources and they send me for review that okay, these have we have found. So this bug is about how a person found out a bug worth $3,000 by just using recon. So what are the steps? For example, there's an target known as star.example.com. I assume you guys have already know about these things, but if you are new to this course, this series, so what you're gonna do is just go on to Udemy and write top 100 interesting bugs, right? Just write these things, top 100 interesting bugs. So there's a part 1 of this course too, so that you are very well known about what I'm talking about. So just take this part first before taking this one, but I would try to make keep it simple. So when you see a scope of a target, it can either say example.com into their particular scope, or they can say star dot uh, example.com. So when this example.com, it means only a single domain is allowed. When they say like this, so multiple domains like are allowed, like the subdomains are also allowed, which is known as a wildcard entry, right? So in this particular case, it was a wildcard entry. So we can use tools like ama subfinder to find all the subdomains. Out of those 600 subdomains, the hacker looked at this particular subdomain, which was named as internal dashboard.example.com. Now, after this particular thing, what the person did was that he came to a conclusion that I would use HTTPX to identify whether the domain is live or not. So he used a tool known as HTTPX, right? HTTPX responded with the status code 200. That means the domain is live. Moving on, when he used fuff, you can use Durbuster, you can use GoBuster at this particular place. There's no restriction on the usage of tools, but it's always good to use fuff for discovery. And after using fuff for discovery of the endpoints, he found this endpoint known as adminconfig.json, and inside of that file there was this particular information which says db username root, db password super secret password 123 hash. Now everyone knows db stands for database. It has the username and the password of the database. The hacker validated that is it the right username and the password and reported it to the company, and he got $3,000 for this particular bug by just doing the proper recon. So recon is the key, guys. Moving on to this bug, where it took the hacker 10 minutes to find a BAC. Now BAC is broken access control. That means you can create, edit, modify, or delete any information that doesn't belong to you, right? That exposed every user profile. So he was hunting on a target where he found this particular endpoint, a get request with API users current. As its name suggests, this API is responsible for sending back you the information of your own account, right? Current. So it returned the information like this. Now the hacker thought, what if I delete the word current and send the endpoint just like this? Get API users. So there was no security. He got the information of all registered users. So simple bug. There was nothing so technical about it. But why I like this bug and why this is on my list is to just showcase that sometimes you might get bugs like that API users current refers to our account. What if we go to get API users, and sometimes this thing might have a security. So try changing the request methods. Try changing to post, put, delete different endpoints, because some endpoints might have a security, some endpoints don't have a security. So always think that way. Coming to the fourth bug, how a person clinched $500 within minutes, right? So this is a particular scenario where a person was testing a website where you can create flashcards, and he was trying HTML injection in every endpoint. So when he injected this HTML payload into the name or title field of the flashcard, he thought that XSS was possible, but nothing happened. But at the same time, he thought of looking at the source code of that particular page. And in the source code, he found out that there were email addresses of multiple staff members and a lot other things and the passwords. And that was a bug. That was a PII, information disclosure. So how it worked is he injected a HTML payload into this particular endpoint, into this particular endpoint. At the same time, some employee might have seen that page. So the employee details got embedded in the source code of that particular page. Now this is a coding flaw where the secrets are getting stored on the front end. So it's always good to check the source code when you are executing some bugs like HTML, XSS. So this was a P2 to P3 level of bug, but it comes with a bit of luck and reviewing the source code. So there was nothing technical about that particular thing, but it's always luck. Sometimes it matters, right? Moving on, we discovered this thing. All right, how the person discovered an IDOR. Now, for you to understand IDOR, you should know the meaning of IDOR. So, IDOR refers to indirect object references. Same thing, it falls under the category of BAC, broken access control. So, if you can create, view, delete, modify the user details of other people, it's IDOR. So, there's a remix feature in Chat GPT, right? Chatgpt.com. So when you upload a particular image, it gets a string like this, media alphanumeric string. So when he kept on uploading a lot of images, he discovered that these strings are not really random. It has a prefix that remains constant, and the other part of that particular link is something that relies on the timestamp of the image being uploaded, at what time the image are being uploaded. So if it consists of 3 bits, this bit is static of the image, and the rest of the 2 bits depend upon what time the image are excluded. So if we can make a code, let's say, okay, make a timestamp from 1 p.m to 1 a.m to 2 a.m of this date, so we can easily make this bit of code. So that's what he did. So what he did was that he started predicting media IDs, which was easy because it relied on the timestamp. Then he used the remix function to inject that newly discovered image IDs to test the impact. So when he made a script used into that remix function of the endpoint, he was able to edit pictures which doesn't belong to him just by enumerating the IDs. So this was a classic IDOR example when you think like an hacker and you are able to exploit things which are beyond your normal capabilities. Moving on, how exposed API keys led to arbitrary account creation. Now, a person was hunting on redacted.com. He was doing the JS file analysis. When you go to any website, let's say you are on this website, you can do a lot of things over here. You can go to more tools, you can go to developer tools, you can go to network, you can go to performances, memory, you can go over here to check the JS files too, right? You might use some tools to check the JS files. So what happened is when he was analyzing the JS files, he got across some files known as chunk vendors some string.js, and in that particular JS files, there was a view app AWS API key getting leaked along with the endpoint. So when he opened this endpoint, he tried to open this endpoint, it showed an error because you are not authorized. When he used this endpoint with the API key that was leaked, it gave access. And after it gave access, it showed something like this: tokens consumed. For those who don't know, that AWS keys are paid per use. So we can abuse this functionality too. But at the same time, when he used to visit this endpoint along with the API key, which he got from here, he got the access of whole website. He can manipulate anything in the entire database because it was relying on GraphQL. So he can do attacks like XSS, admin account takeovers, hijack all the sessions. So it was a very high severity bug because he can create any arbitrary user because he has access to the GraphQL mutations, all because of the JS file leaking this API key and this endpoint. Right? Hope you enjoyed this particular bug because it was simple yet very effective. Now, this is something which is a clear example of uh, why you should do Portswigger Labs. This exact scenario is in Portswigger Labs, which I'm going to discuss now. So, what happened in this particular thing is just the crux of this particular vulnerability because it's very interesting. So, this there is this website one. You find XSS in here. One second. Yep, this is this the website one. You find a XSS in this particular website, but that only works with the post method. Now you know that post based XSS, which only executes at your browser, are known as self XSS. Self XSS falls under the category of a P5 bug. That means it's not that critical. So, in order to make this XSS exploitable and result in something good, you need to link it to CSRF, cross site request forgery, in order to make it work. In order to even raise the impact, you need to find another domain of this website and find another XSS on this, link these two bugs to this one, resulting in a full account takeover. Because using this XSS, you can create cookies on this particular domain, and using this XSS, you can do a full account takeover. I'm leaving this particular thing because it's a exact same lab on Portswigger. You can always do that. Now the other bug says from path guessing to dashboard takeover. How it works is that he was reviewing a website where each country has its own login page, like login New Zealand indicators.php. For Australia, it might be like login Australia indicators.php, login India dot underscore indicators.php. What if instead of login, it's like update New Zealand indicators.php? So when he tried that, he got the access to the dashboard of New Zealand for that particular website. No login required, no session, no token. You can edit country indicators, upload any files, save changes. Same happened for countries like Japan, Turkey, Sweden. So it's like not a basic vulnerability, but a basic example of how you can use your common sense sometimes, and it might result in bugs. Always, it's not important that you find stuff which is technical. It's up to how you use your common sense. Moving on, how this person got his first bounty with just one simple step. So he was hunting on this particular target app that he found interesting and mature. While he was doing the manual recon, he went into a file known as robots.txt. Now, robots.txt is a very common file that most of the websites have for hidden paths. Then he tried doing XSS, open redirects, and IDORs, but nothing happened. Then he used the burp suits history to analyze the endpoints very closely. Then he again went to that robots.txt file and Notice that there's an endpoint known as admin, right? Slash admin. When he tried visiting that admin endpoint, the server returned 403 forbidden. 403 forbidden means you are disallowed, but you can use headers to bypass this particular thing. You can add into these headers into a burp suit request in order to make the server believe that you have access to that particular resource. You can use path variations like admin slash percentage to e, and a lot of things. One prominent method that works for me half of the times is changing the request method. Change get methods to post, post to get to put to delete. You can always do that. So when he tried changing the get method to post, he got access to the admin panel. When he tried to get into the admin users path, he got access to the admin users directly, and the admin panel was leaked. It was a P1 bug, so he got a bounty of $1024 by just using the conversion of get to post method and trying to break the admin endpoint. It's simple, but you need to remember that if I'm getting a 403, I need to try get and post, right? Moving on. So here was a bug. It was a really interesting bug. Let me explain over here. For example, you are on a shopping website, let's say abc.com, right? abc.com, and abc.com has a sale on selected items for, let's say, 24 hours. So for today they discovered that okay, on one fold 5, if the mrp is, let's say, $1,000, for 24 hours we are giving one fold 5 for, let's say, a dollar 700. So if you add things into your cart during that particular time, you would get this particular discount. So what the hacker did, he added 10 folds into the account that costed around $7,000, but the original value at the back end was $10,000. $10,000. So the discount value is around $3,000. And along with this particular thing, he added a TV which was not on discount, but it costed around $3,000 at MRP. So the total cart value of this particular thing was $10,000. What happened was, after the discount ended the next day, it still remained $7,000. So what the hacker thought, he discarded all these 10 folds out of this particular cart. But the server believed that it needs to give $3,000 discount to this particular person because this discount was not linked to this product, but it was linked to the cart ID of the user. So what initially happened was, he got a TV of rupees $3,000. He got a discount of $3,000, which was initially meant to be given on these folds, and the total cart value was $0. Bug P1. So it was like a logical flaw, but it was really interesting. That's how it happened. Hope my story made sense to you guys. All right. Moving to the next bug, we would only do 15 bugs in this particular video, then we would do it in some other video. So this plain sight bug resulting into a full account takeover, how exactly thing happened is, okay, so he was going through the website where he can create a new website, and he was redirected to the website's dashboard. Inside the dashboard, he noticed that the feature integrates with New Relic, a third party service. That's good. When he clicked on that button, it says activate New Relic Pro. That means there's a website. Just to explain you, there's a website. When the person signed into that website, he went to the dashboard of that website. On going to the dashboard, he discovered a button that says activate new relic dashboard, and this new relic dashboard is something related to the third party services, right? So when he clicked onto that dashboard, a new relic dashboard was created without any password or login. So it's good that you are a user, you got a new relic dashboard without any further authentication. But here was the catch. When he was trying to access the new relic dashboard, when he intercepted the request using burp, the new relic dashboard is created on the basis of site id. So the hacker thought, what if I know the site id of the victim? Things are normal only when you have your own site id and you can create the dashboard of your own company for relic. But if you know the site id of the victim, and you can have direct access to the relic dashboard of the victim, it's a bug. So that's what he did, that he got the site id of another organization, pasted it up here, and he directly got the access of relic dashboard of another account. On doing a lot of research, he got the site ids of a lot of people using web archives or wayback urls. He used those site ids to get the whole account takeover on a third party service, that was relic. So it was really interesting bug where you chained two bugs together and it really made a lot of sense, right? Moving on to the other bug, how I found 30 security vulnerabilities in a single program. The first bug was html email injection via name field. It's simple. Instead of the name field, when you are asked to sign up, you fill some html tags like bing.com, href, and stuff like that. It always works. Then when you are trying to do the email verification, if something goes wrong in the response, it says false, try changing that to true. It's classic example of response manipulation. Then you find a file using directory busting that is named as api.log. When you see that api.log, you get information to sensitive logs of the website. Rest, there was a reflected xss, stored xss, and time based sql injection, where if you find a um, endpoint which is directly linked to the database, how you know that? You put this single colon, like colon, and if it leads to an error that's related to sql, you can always try this particular thing. If the website sleeps for 6 seconds, you discovered a blind sql injection. This was something that was quick, and it was good that I thought it's beneficial for you guys. Then 12,900 bounties in the first case using Axiom Classic. It's no promotion from Axiom, but I felt this really good. So Axiom is something like that. It's an automated reckon flow. You collect all the root domains of the websites you wanna see. Then they use Subfinder for subdomain enumeration, NU for finding unresolved subdomains, then the pure DNS, then HTTPS for checking that this domain is live or not. Then use nuclear templates for vulnerability analysis. So he used Axiom along with the combination of nuclear templates to do that. I use that too, and there are some free alternatives to do this particular thing known as Magic Recon, and the other tool was Reckon FTW. You can always use this tool. So I choose this bug to show you a little alternative to using this particular thing. Just two bugs left, and then we are done for the video. Hacker watches what he wants. Free Netflix accounts, so he can watch any movie on Netflix earlier. So he was hunting on a particular target where he found this particular target, where he found a subdomain of uh, Netflix from the source code of what he got. You are like this download.opencontent.netflix.com.s3.amazon aws. That means it's a aws instance of Netflix. So when he used those particular directory, he could see the directly listing of all the movies. So yeah, he can pretty much watch any movie if he goes through that particular directory listing. So it's a classical example of unprotected S3 directories, and the company needs to safeguard that. So big companies do that mistakes, right? The last bug for this particular video is how git config made that person earn money. So he was randomly testing on a target where he visited this endpoint says .git.config, so it showed 200 okay, and it downloaded a config file. So you can use this tool known as git dumper. What git dumper does is you need to do like this: git dumper.py victim website name .git, and it would try to start getting the previous versions of the git that were injected into the particular GitHub repository. And what you can't believe, I discovered it the same bug somewhat like this, and there was whole source code of the website with database passwords and everything. So always try going to .git config endpoint. It's always good, and the same happened with this particular thing. That's all for this video, and see you in the next one. Thank you. Hello everyone, let's get back into the course, and we would try exploring up to bug 50 in a single video, but let's see how it goes. Over here we are with the 16th bug. That's the Confluence takeover, how a simple support email gave me a full wiki access. So the person was testing the system known as company.com, like it's an alias, not a company.com, right? These systems usually have a support email like support at the rate company.com that automatically creates email with the ticketing system. So he just mailed the support at the rate company.com. A few minutes later, he got an email with an invitation to their Atlassian instance. And when he clicked onto that particular thing, the invite, he went into that particular Atlassian server. At the first, nothing seemed so tricky, but the fact that a random email created a user account inside the Atlassian server. So when he accessed that particular thing, the portal has some features that were supposed to be internal and accessible to employees only. He reported this issue, but the issue was marked duplicate, right? But he never stopped. Then he started exploring other things. Atlassian instances often run multiple products under the same domain. So this Atlassian domain looks something like this: target.atlassian.net. So he browsed for Jira servers, browse, admin panel, Confluence spaces. Without any hope, I started typing out Jira admin, but you don't have access to that. After losing hope, he tried to enter this wiki endpoint, and it said you don't have access, but it didn't happen. I got the full access to the company's Confluence server, and inside the internal wiki server, there were internal architecture diagrams, configuration documentation, and it was not now marked as a duplicate because it was a sensitive bug. So he got a 4-digit bounty, and that's why try harder, right? If you got a duplicate, just try to enumerate more and you would be good. Moving to the 17th. This is bypassing 2FA in a public bug bounty program. How it happened was I entered a random OTP and captured the request in Burpsuit's proxy and sent it to the repeater module for further analysis. Instead of forwarding the OTP request, I dropped it entirely. The OTP verification request included a WebJSON token with an authorization header. This was a critical flaw as the JWT appeared to grant access to authenticated endpoints. So what's happening is that the JWT token, which is responsible for authentication, is getting granted in the 2FA flaw itself rather than after the 2FA authentication is done. So he used that authentication. So the request looked like this, but this JWT grants to access to a lot of authenticated things. So what the person thought of that, he got all the parameters which are used post login for authenticated functionality, and try using this authorization token, which is technically incomplete because the 2FA is not yet done, but he used this particular thing to do some endpoints, and he gained access to all API endpoints. So this was a $4,000 bug. It was easy, yet it was good. After the fix was implemented, he started exploring the functionality again. Everything was fixed apart from this payment order page, and he was able to access this payment order page and do a transaction. So the company gave him 2000 more for finding this particular thing, and the total was a $6,000 boundary. The key takeaway from this particular thing is that the company shouldn't leak the JWT token in the 2FA authentication pages. Sometimes it might give access to a lot of authenticated functionalities. When an Android app whispers secret, how it happened is that he was testing a Android app and he was using ADB Logcat to find the logs of that particular mobile app. Let's call it example app. And when he was testing, he found a lot of plain text emails, raw passwords, session tokens in plain text. So by using logcat, right, the test passwords look like this somewhat. So how it worked is that you use a example launch app, enter any dummy credentials and run this command adb logcat for getting the logs out of that particular Android app. And he got this email entered and session tokens in the form of JWT, which is not a good practice. And yep, that was a bug. And it's the rest of the article is about why you shouldn't store sensitive information. So the key takeaway from this particular thing was that you should not use plain text information in the logs. Another thing, unauthorized privilege escalation in role logic. He was testing a system where there were two types of privileges, one with the admin, one with the owner. So admin has the access of manage user settings with some restrictions. Owner has full control, including deleting the organization. In this case, admins were not allowed to delete the organization, but I found a logic flow that admins to assign themselves the owner role without any approval. So how it worked was that create a new organization, invite a second user with the admin functionality, log in as the admin user, go to add people, invite your own account again, but this time as owner. Notice that the invite is automatically accepted on your role is immediately updated. No approval from existing owner is required. So it's like a logical flaw. It's nothing like a bug. The the developers made a mistake in this one. So not now that I'm the owner, go to the organizational settings and delete the organization. So it was like a something that was bad at the developer's perspective rather than anything else. So it was a luck by chance thing. So yeah. OAuth open redirect to account takeover. This is the same lab, I guess. There's a lab on Portsfigure for this one too. Not, I guess, yeah, there's a lab. So when you use a OAuth endpoint like the Facebook, it looks something like this. Login.redacted Facebook return URL and this particular thing return. So he played with this return URL parameter. He tried these things redacted. It's success when he tried to go to our own web servers to get that particular code. It didn't work. But when he used this mutation like https my server at the rate www.redacted.com, it worked. So it looks something like this, my server. So once you can send this to your own server, you can check the logs of your own server to see the OAuth token in the request. Then you can use this OAuth token to get the session cookie and you would get a full account takeover. So yeah, this was good. I personally liked it a lot. Then moving on to the 21st, I adore how I added my own dishes to a restaurant menu. So the story, there was a program which has two types of users, manager user and a customer user. If you own a restaurant and want to list it on the app, you are a manager user. If you're looking for a restaurant to book for your date or something else, so this is kinky. All right. So I first created a customer user, but there were not many functionalities to look for. Everything was limited until I could book a restaurant. The program prevented testing on real restaurants, so I opened the manager domain and started filling in a fake restaurant. So now the tester is doing some testing on the manager privileges. He noticed a function in my manager account where I could open my menu in three ways: PDF file, menu link, image files. Just a second, guys. Sorry, guys, got an important meeting. So, yep. Getting back to the point. So, I noticed a function in a manager's account where I could upload my menu in three ways. That's PDF file, menu link, and image files. right? So I uploaded a PDF file and captured the request. It looked like this. It was a GraphQL endpoint and with a restaurant UUID. And yep. So the thing that might have caught his attention was the restaurant UUID. That's a unique identifier. I can created another manager's account and swapped its restaurant UUID with my target restaurant's UUID. However, when I sent it, I received the following response which says unauthorized. I tried the same thing with upload image method, but it returned the same response. I didn't expect that add link method to work either, but I decided to give it a try. I captured the add link request, swapped the UUID, and it worked. I opened my secondary restaurant account and noticed that added link web page was now displaying in the restaurant's menu section. But here's the problem: restaurant UUID is a unique identifier that only the restaurant owner knows. If he can't brute force it, the report would be informative or like any. So I opened my customer account and interacted with the restaurants in every possible view, search of restaurant UUID, and then in the add to favorite function, the restaurant UUID was getting leaks. He reported it to Buckrowd and he got the bounty. That's simple. Next function, same bug, different places. That's bug number 22. No rate limiting, no tokens, no just cookies and three juicy bugs. So how the bug started? He tested no rate limiting on a endpoint to vote players. So he voted once. He tried to vote again. He said not allowed to vote twice. So he started thinking. When he looked at this endpoint, there was a certain thing known as CUID that was responsible for identifying that particular thing. When he changed that CUID value, he got to vote again and it kept on repeating. The same bug was on reaction on post. So the only identifier that was responsible for the post was CUID, and he could do any rate limiting attacks, right? And then it comes to this particular flaw: business logic, broken wallet, hacked OTP bypass. So how it worked was, there's a website known as redacted.ai. It's a AI based job matching platform. Lets users sign up using email, verify their account using DigiLocker, reward actions with wallet coins, provide virtual assistance and job matching. So he did these bugs, but how exactly everything started? Redacted AI used 4-digit OTPs for login and forgot password flows with no rate limiting, so he could already do the no rate limit attack and gets the right OTP. So that's the first bug. It could result in account takeover or a pre-account takeover. Then it comes to the other flaw known as business logic flaw. So after creating a new account, I explored the wallet feature. A pop-up appeared allowing me to request an amount in dollars despite my wallet balance being $0. I sent request of some dollars. Naturally, I intercepted the request using burp suit, but it says insufficient wallet balance. I changed the 400 bad response to 200 and removed the body of the response and forwarded the request further. To my surprise, the front end accepted this and sent post API update wallet balance. In the update wallet balance, he updated this amount and the type from debited to credited, and he got a balance amount of this much things. Stored XSS in resume, so you could upload a PDF file format which contains an XSS or a SVJ, and it works like a charm. And these are the content types which you could use: image.jpg and image.svg plus XML. Moving on, mobile number verification bypass. It might be related to the code abuse too. On the response, it says success false, error invalid, OTP, but you could change it to success true, and it's bypassed. And it's these are basically very common bugs. The one which I liked was of the increasing balance, to be honest. How I tricked a Swagger UI into showing a fake login page. This one was really good. So he was using subfinder to find the subdomains of the target, then using httpx to see which subdomains are live, then using katana to get the endpoints. And when he used this, he got this endpoint and a swagger ui. One dom xss is very famous for swagger ui, but it didn't work. He used xss.yaml and xss.json, which were the important components of triggering the xss using this endpoint api.target and these particular things, but it didn't work, right? It doesn't allow pop-ups. So he made a phishing POC for login.yaml and login.json and hosted this particular thing in here, and it looked something like this. Now this is a fake login page, but it could be used for phishing or tricking internal team members into entering their credentials. And yeah, this was scary because it could lead to phishing or anything. There were no CSPs, no restrict functionality. HTML was not getting sanitized. It was HTML injection, and it was interesting, but something out of the box. Moving on to the 25th bug. I bypassed 2FA using an old secret. This was one of my favorite when team sent me the list. So he was exploring the functionality. I noticed that enable 2FA didn't prompt the user to re-enter their password. This is a P5 bug. Some companies take it as a P4, but it's a duplicate. Then he logged in into the website, enabled the 2FA using mobile authenticator, disabled the 2FA, logged out of the application, logged back in, and went to enable 2FA. Now, instead of scanning the new QR code, he used the old secret key from the previous step to set up the authenticator and enter the new OTP again. And this was accepted. This is a vulnerability that old secret should be disposed of. It was accepted and reported with a bounty of $500. It was a simple bug for those who don't understand. So here's the flow. So you log in into an account, enable the 2FA, note its secret key, like write down its secret key somewhere else, uh, log out of that account, then log in again, disable the 2FA, enable the 2FA. Instead of scanning the new QR code, enter the secret right here. Enter the secret right here, right? Okay, just a second. All right. Enter the secret right here, and yep, enter the OTP which it's showing, and the 2FA is enabled again. It's a bug, right? The old secret should be disposed of. This was really interesting. Moving on to the 26th one, I would try to complete till 15 this video, but let's see how far we can go. How you unlock premium features for free via simple API trick. So always when you test, you make two accounts, one free plan account and one free trial account with some premium features. So when he was digging deeper in the API, he got some requests like post API team current invitations. That is for sending the invitations. I grabbed the authorization token and crafted a simple post request which looks like this. Okay, email what user you want to give, join our team. Then I fired the request. Invite went through successfully. The user was added to the team. Even this account wasn't supposed to have the ability to invite someone. So how they escalated this one is they created two accounts. Bugs like these are pretty confusing for beginners. Account 1, account 2, right? So account 1 is a free account with no privileges. Account 2 is a trial account with certain privileges. On this account, he got a request of invite functionality. He copied that request, got the JWT authorization token, and used it in this request and sent an invite to a user. Now, technically, this invite button was restricted in this free account, but he got the invite button, he used the JWT token from this account, and he was able to send invite resulting in use of premium features. Now, why it worked? Because there was a front end validation, there was no proper back end validation. So he reported that bug and he would have got a bounty, right? That's pretty simple how you use these tricks to do that. Then coming to the case, the uppercase escape, breaking endpoint restrictions. So he this one was really funny. So he got a particular target known as example.com API matrices. Now this is a p4 bug when you get the matrices, and it was restricted. Instead of using uh, matrices lowercase, he used matrices uppercase. And he was able to bypass the restriction of that particular thing, and he reported that bug. And yeah, he got the information. So you could do similar for the health endpoint, admin endpoint, debug endpoint, because when the developer doesn't set proper restrictions, things happen, right? This was a really funny one. Why I told this? Because my point of showing you the bugs is that it should open your mind. What could you try, what could you not try? So how I took a website completely offline with a funky cache poisoning vulnerability. This was really interesting, closely with the Portswigger lab. So he was hunting on a target.com, and then he quickly noticed that the site was next.js and was sitting behind a CDN firewall. While poking around, I saw certain paths assets were being cached, like assets images. This is a common directory that always gets cached. My first thought was to try some classic cache deception to leak sensitive information, but I hit a dead end. Nothing seemed to work. Reading research and write ups is always great. Thank me later, guys. Just joking. So the CDN had some specific rules for caching content. It cached specific paths like target.com, assets, images, and after images, it's pretty much anything, right? It cached popular pages like login and slash. But if the response had 200 status code, if only the login and slash pages showed 200 status code, it only cached it. Then he understood how he can abuse this particular thing to do a denial of service. A normal request in the login page would return a full HTML page, as you would expect. But after digging some digging, I found a special header X middleware prefetch. When I added this to my request, the server completely changed. It starts returning an empty page. So when he added this header to the X middleware prefetch as a header into the request, it started showing blank objects. At the same time, you need to notice that this trick only worked if you use HTTP 1.1. If you use HTTP 2, it would load the login page fully, right? Send a login, and so what you do is send a request to login, add the X middleware prefetch. The server responds with a 200 OK and a blank page. The CDN sees a 200 OK and caches this broken response for everyone. Boom, site is down. Plot twist: after more digging, I realized that whenever I visited the site, the server set three cookies with seemingly random values. Now, it's for the person who has a certain cookies, right? How it works is, just to explain, you go on to the login endpoint, you add that header which gives a empty page but a 200 OK, and it caches it and showed it to everyone, but it's all cookies, it's not globally. So for every session the server gives three cookies. That's what we are talking about. This was the problem. The CDN wasn't just caching one version of the login page, it was cache created a different cached version of the user cookies. This means my poisoned page was only cached for users who had exactly the same cookie values at me. And every time it generates a random set of cookies, my attack was useless against them. So if someone has new cookies, the attack won't work for them. Digging deeper, random isn't always random. So when he researched about this a bit more, and he sent it to Burp Sequencer to analyze the values, this is what he finally found out. They were being picked from a very small predictable list. How it works is, SUG cookies only had one of the three values. To analyze the combinations, he used sequencer, so it only had these three values. SRC had only these values. BISC had these values. So if we take the combination 3, 2, 2, 6, 12, so there were kind of 12 combinations that could result uh, for the cookies to be generated. So he poisoned all 12 combination of the cookie sets using a Python script and a login page. And for everyone, now it shows a blank page resulting in web cache deception. And yeah, it's a P1 kind of. So bringing the entire website down. This was a really cool bug. I personally liked it a lot. Getting to the 29th, bypassing the group member limit with the race condition. This is very common bug. I have done it a lot of times, but why I included it in my list was that some people might find it fascinating. So in some trial version, you have some limits that you can invite 5 users, 100 users. So after dropping the users to 99, the last request use burp repeater as a parallel set of requests, send them on once. Like you can use turbo intruder to do that burp repeater with prepared parallel request. You could do it anyway, so you are able to invite more than 100 users because the concurrency is not properly handled. So it's like abusing things using um, concurrency things, right? Race conditions. Then one more race condition bug is that, let's assume the target is example.com. When creating a new event, the application asks for an event name. If the name already exists, the front end would display a message, name is already taken. So if I have a username, you cannot use the same username. That's how things work. But if you try using a new name, so use a new name but send this request to burp repeater and make 11 identical requests using it, and send them in parallel single packet attack. So 3 out of 11 succeeded in creating events. So you could create this user's name with same IDs. This could uh it's basically medium to high bug, and three accounts are created with the same name. But this is something interesting you could use in your daily day-to-day approach, right? Also same idea, another target got duplicate to triage, right? So yep, that's how it works. But it was a unique bug. I personally liked it because I never tried it in this way. So you always keep on learning. From public sheet to API takeover, how it works was that he was doing a recon, searching engine docs. He got a publicly accessible Google sheet being used as a backend for live data portal. The sheet contains structured tabular data. So he got hard coded private keys for Google Cloud Project private key and everything. So he could use a GCP project by using these API keys. Full column defacement, so he could write any columns in that. He could use those API keys to get the GCP identity access management permission. So basically, when keys are leaked, it could result in very bad things. So it's always good to do some docking. If you find some Google Sheets, spreadsheets, any kind of GitHub repositories, and you believe they are leaking some keys, always try exploring that. How I earned 1752 using just nmap. How it works was, this was a private program or a well-known platform. The scope included a few subdomains and had full of cloud assets, but he took a different network level recon path. So he used this nmap uh, scans to run on this target.com, and he found this jetty server. On this jetty server, he tried with the admin prompt, right? On the admin prompt, he tried it but didn't reveal anything. Then he went on discovering the robots.txt file. It discovered a backup.zip file. When he clicked on that backup.zip, it included the source code of the admin portal, config files with hard coded credentials, and the env files with AWS keys, resulting into a P1 bug. And he was awarded $1752 for this one bug. And yeah, nmap helps sometimes. I always run nmap scans on my target, to be honest, so it's good. How an API token flaw let me bypass premium restrictions. He was hunting on this particular target. When a new user receives sign up, they receive a 21 days free trial granting access to platform's premium features. So if you take a look at what the backend API request returns, it actually responds with error message saying trial expired. So technically, the system says understands that the trial is over. Since the API was throwing a trial expired message, I started thinking how I can bypass it. So he started looking at the documentation. So when he followed along the documentation, so he got a lot of API requests that would have helped it. So what he did was, now I was thinking where this API tokens could be used. So I went on documentation. I found out they had a CLI program where the API tokens could be used. So I installed the CLI program using Brew. Now that I figured out where the API token could be used, the next logical step was to test how I could interact with the platform using it. According to the docs, the CLI allowed users to do a lot of creating and managing apps. So he, even if your trial is expired on the website, using their CLI tool, you are able to do a lot of actions that are initially meant to be expired on their website. So it's like a flaw, and it was a VDP, so he didn't. It was he got $200 for this bug, as there is no potential for business impact because a trial account, so that it cannot support a production implementation legitimate issue will which we will fix. So but it was created that you, even though your web account is expired, you could use these API keys tokens on the CLI to do some stuff. So it's good. I personally like that. 34th bug. I guess we would do till 35 in this video. I guess it would be too overwhelming if we do 50 in a single go. He was testing on this target known as app.target.com/fuzz. I couldn't find anything interesting, so I kept searching with Google Docs until I found some path app.target and this endpoint lead to ctl login.php, and there was a SSO and Azure. When he looked at the JS files using de4js, he found this endpoint ent invite friend bix, which had the utility through an email parameter send registrations to any user. I went to the test endpoint with my background email and received an invitation invite. Using this link, I was able to register, login as an employee, and access privileged information such as name, addresses, phone numbers. It was a $500 bug. So he discovered this endpoint. On this endpoint, multiple JS files were being loaded. He used this tool to analyze the JS files. He got this endpoint from those JS files. He was able to invite himself as an employee, and he got these bugs. So yeah, the people are really great hunters, to be honest. The last bug for this video is massive data leak using unauthenticated ARC gist REST service. So he was using this particular sublister example and getting to see which domains are working or not. So he found one subdomain known as gistexample.com. Upon browsing, it gave him the status code 503 service unavailable. So as usual, we skipped to next subdomain REST endpoint at GIS server REST services. It showed some things, right? I immediately fired this endpoint, and it was containing ARCGIS 11.1 server REST endpoint. As you can see, it contains different endpoints like countries, utilities. I tried to access country endpoint. It brought to me a login endpoint and gave me 503 service unavailable as below. If you see directory, there is service export CSV as below. Upon exploring, this option brought me to task submitting UI, so that does mean it allowed unauthenticated users. Next, I submitted the task. It generated output in zip file. As this is an insurance company, the output contained massive data of farm profiles like location of farms, third party auditing status. This bug was marked as 7 point high, and I was awarded with bounty specifically. So how it's good to fuzz on such domains so that you can discover stuff. So even if the main page shows 503,404 or something like that, it's always good to fuzz. I always get a lot of bounties using this method, and automation is good for these jobs. This was all for this video. See you in the next one, guys. Thank you. Welcome back, everyone. I would try to cover as much as bugs in a single video. This video might be an hour long. Let's see how it goes. So here comes the 51 bug, and it's about how a simple rate limit issue earned me dollar euro 500. Yep. So this was an external program. The person found out using the docs. The doc was responsible disclosure. So he opened up Firefox, connected to the burp suite. This was a Web3 program. So the hacker spent around a lot of time finding bugs like authentication bypass, account takeover, but it doesn't work. So I noticed the site was very slow and showed an error whenever I clicked a link. It was frustrating and time consuming. So I logged out and decided to test for low hanging bugs like rate limits. I visited the reset password page and sent a reset link. After sending 5 links, it started turning 4 to 9. So too many requests. It's like a basic rate limit thing that always happens with every website. This meant basic security was implemented. I tested step by step to figure out whether the site blocked my IP or the session. After this, in the first few attempts, I bypassed their logic because I noticed that the URL used a custom API call known as v1xyz reset. So I directly appended %2f. That's like a URL encoded slash to the end of the URL. It bypassed the thing successfully, and he was able to send 100 links within 4 seconds. Many beginners would start writing the report at this stage, but I waited because many projects reject low impact bugs, so I wanted to increase the impact. I collected company's email address from GitHub and Google, and he basically sent the email towards the internal company's mail. The company replied 3 months later saying that the team decided to give you euro 500. This is very high because it was a Web3 program. Don't expect such bounty from normal programs. It's generally around 100, 150, as the person said. So yeah, this was a case of where you bypass using a percentage URL encoded slash, right? Getting to the 52nd bug, you are missing out on bug bounties if you don't hunt this bug. This is a bug of credential stuffing. This was something new for me as well. So you can use websites like breach collection to get user emails and passwords for the company. So yep, all you do is go to these websites, breach collection, try to get the email domain or email domain for the website. You would get a list like this: email and password. Try on their domain on admin panels, and you might get lucky. So this was something new. And I again say, I'm not sponsored by any of these websites. It's just I'm telling you, like, out of curiosity, right? Moving on to the 53rd bug. This was about mobile hacking, how I cracked a banking app's pin in 10 seconds. Let's see how it goes. So let's click on the free link to get this. Yep. The golden rule of mobile hacking: if the app trusts the client, you win. Most mobile breaches happen when there are hard coded strings, secrets in strings.xml, insecure local storage, using keychain shared preference, lack of certificate pinning, easy MITM, man in the middle. Download the app, he used Genymotion. Install the target app from APK Mirror. Always test older versions, they are weaker. It's something that's not recommended if you're doing on bug bounty platforms, because they explicitly say you need to test on the latest version. Sometimes they just don't pay you the bounty even if the same bugs exist on their latest application. So just a quick tip from my side. Then the person ran mobsf for quick wins. So he ran mobsf, uploaded the APK file to mobsf, and he found some hard-coded AWS keys in res value string.xml, disabled certificate pinning in network security config. So he bypassed the SSL pinning using objection com startup command, Android SSL pinning disabled. Saw this API call after login. So that means they're converting the pin to SHA-256. They has the pin client side before sending. So this is over reliance on the client side architecture. So the person wrote the script to dump raw pins before hashing. Java.perform This is like the application structure dot pin utils, the function they are using. Pin entered, so ran it. So once you entered the pin like 19841234, so it's like you can try that. The app didn't even have rate limit guesses, so you can do that. Use the pin to disable biometric authentication. Change the passwords via change password thing, because you know the old pin, so you can always change the new password. Write a Python script to brute force common pins. Found 7 per users of used default pins. Reported with a devastating POC video bypassing biometric authentication. Spreadsheet of test account takeovers. Legal memo of regulatory fines. That could happen because it's plain text. And yeah, the person got into that particular thing. 2025 mobile attack hotspots. So iOS keychain entries to dump. So you could use this particular thing to see the keychains of iOS. You could use ADB shell to see our Android shared preferences. Then biometric bypasses. You could use biometric prompt authenticate. Lack content is always true. Deep link hijacking, from where he got the reset password button and how he knew what he needs to do. Exploit with ADB shell. Token is equal to admin. And there are a lot of things which you could learn from this particular thing. So anyhow, I would be leaving this particular Google document for you guys to read and learn more. Coming to the 54th bug, it's about logs. Logs don't lie. How a GraphQL debug lead to the entire thing. So let's read about it. We clicked on the free button. It might take some time. Yep, it's loaded. So here comes the step one, that you run subfinder on the target. Then one subdomain grabbed the attention, that was debug api.target.com. The word debug in production is not good. That's like finding an unlocked diary in high school. That's right. Hitting it in the browser gave me a GraphQL playground UI. Interesting but wait, that this wasn't standard production schema. It has an hidden endpoint, GraphQL debug. So when you see this endpoint, it has the GraphQL and introspection enabled. And if you have GraphQL introspection enabled, it's easy for you to understand the structure of things. So you can see server logs. Once you fetch that server logs over here, it showed you full SQL queries from with bound parameters, that how exactly things are working. This is the password hashes. So you could always search for other things like SQL, and you could do SQL injection from GraphQL, right? Then you could do this select star from users, as I said, and it would show all the users, and it could result in a full DB dump if you have GraphQL running. And so the thing that stood out was finding this domain which stood out, revealing introspection is enabled, then getting the logs and query history, and how you could dump the DB dogs. And so debug endpoints in production are gold mines. Look for slash debug slash internal slash test API. If the GraphQL doesn't work, you could use GraphQL debug. Sometimes the name is like debug GraphQL, GraphQL debug, GraphQL. It's like you could trust the mutations. Then schema discovery, what are the schemas they are using? Sensitive logs retrieval, then the database dump. So it was good. Moving on, I guess it's the 55th, right? Let's click on the free link. Mirror in the cache, the day I become a digital pickpocket. So how it worked was, step one, using a mass sensor finder to find the domain. So one thing that caught his attention was mirror minus api dot target.com. Sounds harmless until you realize mirror often means we just spit back whatever you give us. So first contact with the mirror, he used curl to just test it. So it just said curl I mirror api target.com slash reflect an input test 1 2 3, and boom, it was my test 1 2 3 proudly echoed in the HTML response inside a JSON block. So you could do a lot of things into this particular thing. While fuzzing endpoints, I stumbled upon GraphQL. So the introspection was enabled again, right? There was something juicy that said get user data by ID. So weaponization reflection. So how it worked was, I realized that the reflected input was also cached aggressively by CDN. That meant I could poison the cache. You should do web cache poisoning on Portsfigure if you don't understand this particular thing. Curl x get mirror API reflect input, and any input you give is getting cached. So into the input you insert the script evil.com payload.js. So from this particular thing everything would be cached and x forwarded host victim.com. Thanks to the cache, any victim loading the endpoint would get my payload, which could exfiltrate the raw token. So this was a web cache poisoning. So once person used that, with token stolen you could use this GraphQL endpoint which has the introspection enabled and their ID over here. So you could get their email, phone, SSN, credit card and everything. So how it how you should document for getting maximum reward. So reflection bug allowed HTML JS injection. Cache poisoning made it persistent for all users. Token theft gave me GraphQL access, and PII disclosure. It's like a P2 or P3 bug. And that's what I guess he says. 3 trays of Red Bull, it's a lot. In Australia, it's costly. The Red Bull is costly. Getting to the 56th bug, JWT. Let's go to the free link to see how it goes. Alright, so from here it starts that he was casually hunting and it was going for a failed attempted, but I tried to dock for finding Atlassian dashboards, but which was having some text related to the target but was not of the target, but it was highlighting when I visited. I could see some updates. You are viewing this with anonymous access with some content might be blocked. So when he was testing for the Atlassian dashboards for the target, he found this particular thing. But then it suddenly struck me to check the source and check if I can find something hard coded. First, I checked for JWT and found something interesting. This was a JW token that starts with EYJHP. It was long enough, but then I was in disbelief that this was real. As soon as I got the JWT token, you could go to jwt.io to see if it's working. After this, I was keen to proceed, forgot all my sleep. It was already 2 a.m. So got started with creating a curl request for check if the token is valid. So he used this as a bearer token on this particular website. As soon as I click enter, you got the whole Atlassian server access. This was the time it was like great work, man. If I can, you also can just keep trying. So it's just look at the source code, just use the JWT to embed as an authorization token. So it's like most client side reliance, and it's like a luck based uh, thing also. But you should know if you get across these scenarios how you should be finding things. And a special shout out goes to this particular person, Iski. A lot of bugs on this list are by him or her. I don't know if it's male or female, but it has really great bugs. So yeah, thanks goes to him and as well as all other reporters who did so much great write-ups, right? This they say a picture is worth 1,000 words, but in my case it was worth a reverse shell and a critical report and a 4-digit bounty. Looks good. Also, me 2 weeks before UG, another upload endpoint probably just rejects everything except JPEG and PNG boring. But 2 weeks later, I got a RC by uploading a selfie with an evil surprise inside it. How it worked? He used Subfinder for getting the subdomains. He got one endpoint which says media upload, API v2 image upload with a content type multi-part form data and Swagger docs that whispered sweet secrets. File binary. Oh yes, a direct image upload endpoint, no authentication, no CSRF, nothing. Testing the filters. To be honest, I wasn't expecting much. I uploaded basic JPEG PNG files, even through a PHP file just for fun. PHP got rejected, but the JPEGs worked. So if the JPEGs worked, he used a mutation. This is very common mutation in Portsfigure labs. You could also try that. It works something like shell.php.jpg. So for the people who don't understand, JPEG is like JPG or JPEG, right? So what if it looked like so? Curl request, the file name, and the content type. They stored it on a S3 bucket like this. So far harmless, but then there's where the real fun begins. Just like yeah, where the real fun begins. So he used exif tool to embed a comment, something like get cmd shell.jpg, and move this file like renaming this particular file. MV is used for renaming sometimes. So upload again, still accepted. Now I checked if any backend service was parsing this as PHP. So I tried. This was parsing it as PHP shell.php.jpg. Command is equal to ID. Nothing but I remembered some backend system, especially if provided by nginx with poor configs, may treat differently. Time for deep testing. So he uploaded that particular thing. Upload the file, then first alternative access path that may treat jpg.jpg as PHP. So using fuff he got these particular things. Where shells.txt included things like this, right? So he got a hit like shell.php rendered the file as PHP, and it resulted in code execution, right? So it was like a shells.txt where you just simply give the mutations of everything, nothing else, right? So he got this particular thing. Who am I? It says www data, and then he ran a request to the burp collaborator to see if you are getting a ping back. And if you are getting a ping back, you have a whole RC working, so it works good. Use .phar extension trick with image headers, dry double extensions, bypass mime checks, magic bytes always works. So yeah, this was a clever RCE. Kudos to the hacker. 58. Oh, secrets are on Google again. So he was docking on example.com. He found some Git repositories. Gits are always good. I have already covered a bug on git.git. So you got the old backup files, you could find the exposed documents. So there is a list of Google Docs which you could always use. It's not like a bug, it's like a list of, it's like 58. You could always see that and use that in your bug hunting journey. Coming to the 59th bug, I guess a whole 50 would be a lot long for this video. I would cover 25 like till 75, and I guess that would be all for this video, and then another 25 for another video. So what I found while testing a car marketplace platform, I discovered a business logic that allowed me to manipulate subscriber counts. So how it worked was, create two accounts on different browsers. Account A, main browser. Account B, exploiting a profile. Log in as account B and subscribe to account A. Delete account B. Normally this should reduce the follower count, but it doesn't. Subscriber count still increased by +1. Keep recreating the count, subscribe it, delete it, resubscribing it, delete it. You could do this indefinitely and you could get subscribers. So it could be a misleading thing if you just keep doing that, and you people can trust fake people on that. So yeah, that was a logic, and he got $40 for this particular bug, but it was interesting. You should always try things like that. Well, this was good. Coming to 60, let's go to the free link. Yep. Ticket to trouble, how I eject support tickets to see everyone's complaint. So how it started, he started doing recon. While running a passive recon session, he got a domain like support.example.com. First instinct, he started getting all URLs for this particular thing, and he got something like ID, this number, but the ID param. So you could do rate limits using intruder to get ID numbers. So just try changing the IDs, and you can see anyone's else ticket. It's pure IDOR. You could do pretty much anything. So while he was inspecting the ticket interface, I noticed that the front end was using GraphQL. So let's play with GraphQL in this particular thing. If you know the ID, you could do a lot of things. You could manipulate it as well. So he was able to get PII data, internal communication, and a lot of things just because of that particular thing. So the proof of concept was getting a ticket ID, replace with another ID, go via GraphQL, and you could do a lot of IDOS stuff. So The enumeration is the key. I personally believe if you do good recon or enumeration, you are two steps ahead of anyone else, and there are very few chances that you would be stuck on some duplicates. Read for free. So manual recon. I guess the spelling of manual is something of, yeah, manula. It's fine. Things happen. No worries. Extracting data from the subdomain graph. So how it works is, so he used this particular docs to get the subdomains, but there were no leader for this subdomain from Google Docs. So how the manual research go is that he used wayback URLs to get the JS files, grep JS. I started manually opening all JavaScript related to subdomain services. After an hour, I got one JavaScript file, which I find just one occurrence of the subdomain. It's obfuscation JavaScript file. Everything is a little bit hard. So what he started doing was subdomain.target.com index.js.html. Again, same response, access denied on the page. So he was not happy with that. So what he did was he echoed subdomain with C, like what if it's working on some other ports. You could use nmap for the same thing, but he used a different approach. I don't know why. So, but I gave another chance with the top 1,000. Well, you could do the same thing with nmap, guys. Just don't. See, the beauty of hacking is you could do multiple things by multiple approaches. Don't stick to just one approach. So again, I go to browser and open the subdomain with open port, and it's access denied again. But he read this access denied thing again. I started fuzzing the directory with port number and double extensions. So he started with the double extensions list, so that after 15 minutes later it got a response with slightly larger data. I quickly opened this particular directory, and there were another other things like db.js.html, app.js.html. I opened all the files manually and got many sensitive things, and he got this particular thing. And yeah, again, recon is the key. Recon is the key. If you do good recon, you are always on a good side. Forgotten by design, how an unused subdomain gave me full cloud access. I was one of the late night recon marathons, so he used Amas, a finder, get all URLs, wayback URL cert.sh. So around 1700 subdomains were collected, but this subdomain got his extensions. The subdomains with staging keywords, internal keywords, dashboard keywords always get your attention. So when he clicked on this particular thing, it gave me a AWS S3404 page. This was the first red flag. So when he did the dig cname analysis of this particular thing, it used towards a dangling subdomain point to non-existing S3 bucket. That means you could create that bucket and own that subdomain. It's a classic S3 subdomain takeover vulnerability. I did it a lot. So how you use that? So now comes the fun part. He logged in into the AWS account and ran this particular thing, unused bucket, and guess what? Success. I opened the subdomain again, and boom, 403 S3 bucket exists but access denied. That confirmed that I was in control. Just to flex, I uploaded a custom HTML file. So you could make a index.html and upload it to that S3 bucket, and it shows like hello from a forgotten dashboard. Refresh the browser, it loaded. It was now hosting content on legit subdomain of a top tier company. But wait, it gets worse. Cool, nice, 2000 bugs, maybe dollars maybe, but curiosity had other plans. So he uh looked to dig in deeper. So he used like web archives to found like if there are any URLs for that particular thing for this subdomain which he owns now, right? Found some juicy JS files from 2022 that referenced admin panels. So consistent API URL. So the archive site used internal APIs and required auth token. So checked if the JS still existed. So he used this JS files and he got a bearer token. So he used this bearer token on this particular staging target v1 users, and he got the full users list. Then there were API endpoint like v1 environment s3 config, which returns things like s3 key, s3 secret, because you are doing the request from a cloud server, right? You have the authentication. So there were another things. So yeah, how a subdomain takeover lead to the whole infrastructure takeover, and that was good. This person is really good. Iski, he's good. I really like the write-ups. 63. There might be some great hackers, but I like the people who are good at writing write-ups. His write-ups are very clean. All right. Clean up how a forgotten admin endpoint let me drop all the data. So how it works was, again, he's a crazy recon guy. He used this get all endpoints and specifically get the endpoints which have these keywords: admin, config, env, cleanup, reset. He got a subdomain which got his eye. App staging, very legit company.com. So it's like not the real name, it's like poking him. He's poking them. So admin cleanup all. So it had all the vibes: exposed admin in path, no authins URL. So he tested if it's real. So he fired up his burp and tested this endpoint with zero header and no cookies. So that's not what I expected. All database entries cleared successful by clean job. So just by using this endpoint, admin cleanup all, that was created by the developer, he wiped the entire data of the company. I reloaded the main app dashboard in another tab. Everything was gone. User data, product listing, transactional logs, 404s and null everywhere. At this point, my heart rate hit a healthy 130 bpm, because in some cases, companies might sue you for deleting everything. So, yep. So he quickly ran this particular thing to register some stuff. So he used curl to register test at the rate pond password app staging auth register. Registration failed, internal database error. Just because he killed everything, the database is not working, so it's dead. The root cause is cleanup all is an endpoint meant for internal quality analysis testing, but he didn't destroyed that, so it deleted all the entire data. So yep, it's bad. But don't try. If you find this endpoint, just don't dare try testing it. Don't expect a bounty. The person would kill you unless and until you are testing on Bugcrowd or something private pen test. So just don't try that. So other juicy endpoints are admin db, reset, internal drop db, qa, init clean, maintenance full wipe. So this might be open on some other endpoints. And final thoughts, uh, he didn't told that he got some bounty or not, but at the end of the day, it's good. The write-up was good. Learn something new. 64, right? Let's see the link. Okay, again, his write-ups are all around enumeration. Subfinder, he got another target: staging, target assets, CDN. Now here's where it got fun. They were serving the entire front-end bundle with source maps. The dot map files publicly. So he used widget to download that dot map treasure, then digged in deep to find some secrets. SK lives are Stripe API keys, which are used for payment gateways. Not just one key, two in production. So he got two API strike keys which are in production. For internal admin token, I found the endpoint, it was meant for the source. So internal API target admin users, he got this authorization bearer token. Welcome back admin, and he traced the origins to find out private npm package from monorepo. And yep, that's how he got everything. He got the source map stack trace by enumerating much deeper. So how he did that, just a recap: he got this endpoint dot map files, he extracted the secrets, then used secrets to hit internal APIs for admins and users, and boom, rest everything is history, to be honest. JS files are gold mines, to be honest. 65. From innocent messages to total takeover. How I attacked the professional network. How it goes is, uh, if you start from here, that you create two accounts. Account one for attacker, account two the target for my experiments. I began testing platform's chat system by sending basic HTML payloads from account 1 to account 2. So first thing he tried in the chat feature was image injection, then trying sending the phishing links, iframe injection. Result, everything worked. The platform rendered my raw HTML payloads without sanitizing them. This was critical. So he used tried to do stored XSS in the chat system. He used this payload, and when the account 2 opened the chat, the payload executed, triggering a pop-up. Even account 1 would see the XSS pop-up on revisiting the chat. This confirmed the presence of full stored XSS vulnerability in the chat system. So full account takeover, you should just grab the cookies of that particular thing. So he crafted a blind XSS payload to escalate the attack. This payload would steal the victim session cookie and send it to the server for exploitation. So you could use XSS Hunter and stuff like that to do the same things, and it resulted in full account takeover. So yep, it was from a website that didn't really bother. That was all for today's video. I preferred doing till 75, but the bugs are very concise. Even 15 bugs are taking half an hour, so I would break down it into smaller videos. See you in the next video, guys. Thank you. Welcome back, everyone. Let's start from bug number 66, and we will try to cover as much as we can in this particular video, but I won't make the video so long so that it's hard to follow. Over here, this is Linktree username validation bypass, a hidden threat with the leading landscape. So how it worked was, during security testing on Linktree's user system, I discovered an input validation bypass that allowed registration of usernames with leading spaces. How it works was, this tiny mistake introduced a serious impersonation vector which could enable phishing, identity spoofing, and social engineering attacks. How exactly it works is that if you have this particular link tree, so you could use percentage 20, that's a space, and it looks exactly the same, but it could be leading to impersonation attempts. And that was all for this particular bug. Why I showed you this particular thing was because even though it's with a leading space, it technically looks the same, and it's hard to spot the difference, right? And this is a serious security implementation of the Linktree user space. So you could do the same in a lot of bugs. My point of showing you the one with leading spaces was you could do it on other things. So IDOR allows zero-click account takeover on a Web3 program. How it works was, let's see into it. I use Wayback URLs to grab previous URLs from the target.com and started hunting manually. I visited the sign up page and started the registration process with the burp suit. I register myself with just confirming my mail and phone number, while I notice a post is sent to server with the mail and following information with zero authentication. So how it works was that you have an ID, you have an email, you have a phone number, right? Then I created my second account and took the ID from that particular account and changed the field of the ID parameter and request to second account. So if you have one ID, you made another account and replace this ID with another ID, right? After verifying a valid mail and number, I got surprised the server accept other number and mail without verification. The server validates the information without checking. I just changed the email and the phone second user to my own, and yep, it particularly works. So I just go to forgot password page and enter mail, verify the mail, got you to set a new password, and you particularly do that. How exactly everything works is that if you log in, you get your ID, email, and password. So you basically save it in one request, create another account, get the ID of account 2, replace this ID over here, and use your email. So you're without validating this request links your ID to your email, then go to the reset password page, send a forgot password request on the email that's now attached to this ID to change the password, pretty much change the password. It would result in a full account takeover, right? That's what it said over here. Moving on, 68th, DNS and deception, how SSRF and metadata gave me cloud access on Silver Platter. Let's see. So he was doing the recon by using HTTPX wayback URLs and GAU. Let's get all URLs. So he got this subdomain which looks something like this: export PDF internal mytarget.com. So he was suspicious. There was no authentication required, rate limit. There were no rate limits. What made it even better? It accepted external URLs as input to render into the PDF using a parameter called this. So this was the request which says export PDF with the URL. You could enter any arbitrary URL over here. So what he did was to confirm the SSRF, he pointed this URL to the burp collaborator, and boom, you got you got SSRF, server side request forgery. And if you have a server side request forgery, you could see this particular information to get the full details of the AWS. So IAM security credentials and the data was infiltrated, and you get a lot of information using this particular thing if you have SSRF. And yeah, that's how he made a IAM role name, and he got access key ID, secret key, token, and expiration. If there's no AWS, it's running on GCP, you could run these for getting the information of GCP endpoints. And that was all for the bug for this particular one, how you get a full cloud account takeover from SSRF. This is relatively a very old bug. A lot of people do that. How I made $20,000 plus from broken link hijacking on GitHub repos. Since I was very active on GitHub at the time, why not scan GitHub repositories for broken link? So how exactly it works is, you can't search the full contents of large repos. The results are incomplete and inconsistent. So what he did was clone all repos of the GitHub organization locally. So if you're targeting an organization, clone all the repos of the GitHub organization locally. Recursively scan all files using regex to extract URLs. Run HTTP calls on each URL to detect 404s not found and 410 responses. I bundled the scripts into a tool where you can find here, with that is GitHub Scanner Local. Real results. I started running this on GitHub organizations in bug bounty programs and saw solid results. Most organizations had at least one broken link, which doesn't work. Around 30 to 70 or 80% of reports were accepted. Bounties range from $100 to $1,500. And that's how it pretty much works. So you could use these tools to find up stuff in the GitHub repositories. This could be misleading as well, that it might not be, it's just a promotion of your tool, but can't say anything. If it's true, kudos to the hacker. I personally feel that he has attached some screenshots over here, but yeah, let's not go on to that aspect. Our motive is to just learn things if something's new. How I took over a forgotten Google storage bucket used to distribute Helm binaries. So what exactly he did was, what this bucket was, this was a GCS bucket, Google Cloud Storage bucket. How he got this particular thing, it was everywhere and it was broken. So I checked Google Cloud. This bucket had everything, but it was unclaimed, like the S3's stuff that is unclaimed. So I registered the GCS bucket with this particular name and hosted a harmless takeover.html file to verify that you have control over it. Then I ran GitHub wide search and found thousands of open source projects still referencing to this exact bucket. Dozens of bug bounty eligible companies either using or forking these projects. And why it was dangerous, this wasn't a broken documentation link, this was a binary distribution source. So this bucket was stored for binary distribution, so that's why it was crucial. I responsibly disclosed the issue to affected companies and maintainers, acknowledged the impact as high, paid bounties accordingly, because many companies were using that Google Cloud Storage for a binary distribution, and he got 100, 500, 300, 250s for this particular thing. So I still own the bucket as of writing this bucket is still mine. So he uses this. Even now I occasionally see new traffic to it, likely from old CI setups. Across my scanning project in 2021, broken links, GitHub username, hijacks, Frogger, cloud buckets, I earned around $50,000 in bug bounties using this things, right? So everyone has their own niche. Someone earns good money from. My particular niche is around broken access controls. I earn a lot of money from that. Everyone has their own niche. Let's go to this bug. This bug is around access denied subdomain bypass. So again, after some days of depression, I came back again to hunting my sole primary target and fired up my terminal to find something new about the target. I started by taking a look at my target subdomain, which I had previously saved using Subfinder. After some time, I selected three subdomains for hunting. I opened these subdomains manually in my browser and found out two web pages are live sites. One is a 403 subdomain with access denied, as you see in the image below. So maybe one question that comes to your mind: what makes an access denied subdomain this interesting that you would leave those live websites? The answer is I was hacking on the primary sole target when I didn't have any idea what exactly to be done, right? So we would dive much deeper into it. How exactly got the attention of this particular thing? At that time, I just used the dir search for directory enumeration on all subdomains like every beginner. So I remember I had dir search enumeration results of this access denied subdomain stored in reports. So everything was fine, just freaking 403 status codes. If you have already read my articles, you know I love go back to my targets where I haven't got anything. So he always does that. Back to square one. I started my research on this subdomain again. I used some pretty general Google Docs. Sub, admin, login, data user. I got nothing from docs. So I fired up my terminal and moved to the target specific directory where I have all the data about this target. I started directory enumeration again with dir search. In no time, my terminal was read with 403 status codes. Then he looked at the wayback URLs. I got a huge amount of data with JPEG and PNG files, but mostly JavaScript files with the same access denied pages. Eyes on the endpoint. Even though all the JavaScript files pages were access denied, I started taking a look at them manually in the browser, hoping maybe I find something interesting. The path of JavaScript is static, something like this. And after half an hour of opening JavaScript files, I found some JSON files among these JavaScript files, and my mind went like there is something I can smell this. I quickly opened the file and with the 200 OK response code, the JSON file opened in the browser where it had all the links of JavaScript files I had previously opened. I can't disclose the JSON path because it's sensitive to the target. Maybe you're thinking, hell, again, there is nothing interesting, but there is one thing that was interesting. This subdomain is not completely access denied. So if you can open one path on a target, that means it's not completely access denied. With this thought in mind, I saved the whole JSON file path on Notion and took a short break. After a short break, after 2 hours of break, I came back. I took the path from the Notion and started the directory enumeration with dir search. So how it worked was dir search subdomain part to the JSON file. What was that JSON file? And this 403 response particularly. Hoping I got another JSON file that exposed something, and in parallel, I started looking very closely at the wayback URLs data again. This time, the thought was find something that looks like the path of JSON or another file like JSON. After quite some time, I checked the result of dir search, and there wasn't a single file exposed on this path except that one JSON file. My only hope was wayback URLs. I started looking at the paths more closely, got one single directory on that subdomain. So it exposed this directory, that was directory 1. This looked similar to the JSON file directory but not the same. I started enumerating using the search again and I got one file only exposed, that was app.js. I started reading a JS file and found some directories and one of them stood out. I started enumeration again on this new exposed directory. Let name this directory 2. I got another JavaScript exposed which was revealing the internal structure and some key patterns of custom directories. After some time, I noticed one pattern. These custom directories are themselves a file with JSON extension. So how it works was subtarget.com directory 1, directory 2, new directory.json. So I started taking a closer look at these customized directories with their files. There was nothing interesting, but at the very bottom of every file, the employee's email address and internal Bitbucket repositories were fully revealed in the plain text. Now, once again, what's the trick to bypass access denied? You need to find that one direct to the subdomain which is permitted to access either from your enumeration tool or by reading documents. And when he reported this particular bug, I made a detailed report about all my findings and reported it to the security team. and they were able to reproduce it. So he got system exposure of internal files, developer artifacts, and metadata. It was identified as a low severity, so I ended up getting certificate. Just 2 days before publishing this blog, I got a critical bug on the same access denied subdomain, which was related to private SSH leak. It's worth it to look again at your findings. Maybe something hits you at that time. I will be publishing soon another use of this technique, and yeah, that this was pretty much good approach. I personally liked it a lot. Euro 100 in seconds. Lots of bug hunters miss this bug, but you don't. That's broken link hijacking. I won't be caring much on this. That you can find broken links hijacking, and there's a tool known as uh, Subzy or something. SUBZY. If I'm not wrong, you could use to that to get broken link hijacking. You, or if you are my students, you already know what this broken link hijacking a lot. So I wouldn't be covering this thing. 73rd, simple email HTML injection leads to $250. How it works is that while testing a support form of a popular API based video platform, I came across a simple but impactful vulnerability, that's email HTML injection. This issue allowed me to inject HTML tags into confirmation emails sent to the users. While it didn't lead to full accesses, it opened the door to phishing, clickjacking, and user manipulation. Let's walk through how I discovered it. So, email HTML injection occurs when user controlled input is inserted directly. We know that. Navigate to the support page of the target that looks something like example slash contact, sales contact. It can be anything in your case. Then I saw that there was a contact form instead of mail. So, you fill the contact form instead of using your name in the subject payload. You can use something like this. The result, shortly after submission, I received a confirmation email from the platform. To my surprise, the subject input was reflected directly in the email's body and HTML was being rendered. So you see, click linking to evil.com. So this was a HTML email injection. I was able to decrease companies' mail SEO. I actually added this payload for making it so fishy that even Google Mail represent this email as spam or malicious, right? So he used this payload for logging in, but that's not something you should do. If you can demonstrate this, the bounty is going to be same. But he wanted to make this look more dangerous, so he did this. But yeah, Google recognized it that it's a phishing thing. So yep, that was around HTML email injection. 74th, big beginners bug hunters must try this bug. So let's see what the bug is. Hyperlink injection, it's something like when you try to do HTML injection, it doesn't work, so you could do hyperlink injection. So when you open a sign up or registration page, instead of your name, just fill in like evil.com or something like that. Usually you should try for HTML injection, but if it doesn't work, you could do evil.com. If it gets embedded in that particular link, it's hyperlink injection. It's easy, it could give you some quick bounties, but mostly it's duplicates, right? A lot of people do that. A lot of people try doing HTML email injection, but if it doesn't work, they could do hyperlink injection. Pre-account takeover via OAuth misconfiguration. How it works was, attacker creates an account first. Attacker goes to standard sign up page on target.com and registers a victim email using any password. Since there is no email verification, the attacker is immediately logged in. Fine. Eventually, the legitimate user, target.com, sign-ups using Google using the same email. The site lets them in without warning or may ask them to reset your password. So now both attacker and the victim has the access to the same account. The victim doesn't know that someone is using their own account. So yeah, that's the pre-account takeover. It's a very old bug, very classic bug. A lot of people do that. Getting to the 76th, how I cleanse 500 within minutes. This one we have already covered, the flashcards. I guess the team repeated it. We have already done this one. 77th. Cast me outside, how I poisoned CD and caches and hijacked sessions like a magician. How it worked was that find cacheable endpoints behind a CDN. So use wayback URLs, GAU, FFF with common wordlets like web content discovery. So he used this command to get things, used FFF to get the endpoints. He got this endpoint, which was cdn.target.com API internal auth debug environment production. Looks boring. It was returning this admin at the rate target.com auth token read write admin. So you are getting the JW token for admin. That doesn't look good. But here's the catch, it worked only once in a while until I figured out the magic spell. The CDN cached this internal debugger response when the admin hit it and served it to me when I spoofed headers or requested it at the moment. So, key HTTP headers observes the admin hits the debug endpoint from a certain location. It is cached by the CDN. The CDN doesn't care who asks for it, it just serves it to anyone for 300 seconds. I was anyone, right? Crafting the poison. How it works was I made the admin click on the this crafted internal link. So how it works was that if it's caching for the admin, it would show the same thing to the admin as well. So the admin clicked on this link. I sent it via help desk ticket with the usual social engineering fluff. This API gives 500 error when called from the mobile. Please check. Admin accessed it. Response got cached with the auth token and email. Pulled the cache data. So use the curl request to pull the cache data, and you get the request back of the admin along with auth tokens. I literally choked my old cold coffee. I just got admin. Sorry, I just got admin level tokens reflected through stale caches because the CDN treated everyone like they were special. Taking it further, so I went ahead and tried cache key manipulation and host header on other routes. So he used API key settings. So when someone clicks on this X host override admin, there was one another leak, access key and the secret key. So he was basically able to hack a lot of things using this particular method of cache poisoning. And yeah, that's all for this particular thing. 78th, insecure by design. How a mobile API let me reset everyone's password with just a phone number. So how it works was that I was lying there. There are like most security researchers contemplating if the fourth cup of coffee was a mistake. And somewhere between API v2 users profile and my 7 screenshot of 403 forbidden, how everything worked was that he started mass recon, then used GAO, and he got a mobile domain known as mapi looked harmless. But when he started fuzzing on these particular things, he got this endpoint known as API v3 auth password reset. The best part about this endpoint was there was no authentication required. When you look at this endpoint, it's like a forgot password flow for the security. So you just enter a phone number and it asks you for an OTP. When you try to brute force the OTP, you might think it would give a 429, but it gives you nothing, right? So if you just trigger it, it's not showing 429. It says success password link sent to the registered mobile, except no SMS delivered. It was saying it's delivered, but it's not. So I decided to push the limits. So he just used this endpoint, password reset endpoint with new password, confirm password, and guess what? The password was reset. No OTP, no token, no verification. So he just need a phone number to change the password. Right. So I created a quick Python POC using requests and the phone list. So for every list, the password could be changed. In no time, I had access to multiple accounts just by knowing their phone number. No tokens, no link, no nothing. So more than just a reset, turning password bugs into sensitive data. So if I access to someone's account, so you could get access to their critical data too. So yeah, this was a very crucial bug to look at. And yeah, that was lovely. So this shows that you could try adding parameters of your own. It might work in some scenario. Same thing happened with me on a target on Buckroad. It's known as T Mobile. I got a duplicate by 5 seconds. It was a bug for around $20,000. It was a zero click account takeover. So yeah, Similar thing happened with me. So what is stored HTML injection? So you entered simple HTML tags hello from Heath and Caf, and if it's getting loaded, you could use it to trigger accesses and stuff like that. When you execute the payload, it would look something like this: injected div, access click me. So yeah, stored HTML injection is, you could, it might be duplicate, right? Because it's very common thing. If it's vulnerable, a lot of bug hunters hunt for it. There's nothing new about that. Business logic, broken wallet. I guess we have covered this too. Yep, we have covered this too. There are some bugs which are getting repeated. All right, guys, let's cover the last 20 bugs in another video. I don't want to make the one video stretch a lot. See you in another video. Thank you. Welcome back, guys. Hopefully this is the last video of this course, and I hope you're enjoying the course. If you're liking it, just don't refrain from giving a 5 star. And if you have some suggestions, you can always drop that. Secrets and sessions, how a forgotten cookie let me walk into an admin panel, right? How it worked was that he was doing a recon, and I again said huge shout out to Iski. I like the write-ups a lot. So he used this recon for subfinder, and one URL caught the eye that was staging or target logout. I logged in with the test account, opened DevTools, then I clicked the logout. The front end said logout successful, but in the network tab, the session cookie remained suspicious. That was bad. So I thought, what happens if I copy the cookie and paste it into a new incognito after logout? Boom, still logged in. So he knew that the cookies are not expiring. Session fixation, cookie reuse, other login, copy cookie, logout, paste cookie, new tab, access to dashboard, still in. Then came the kicker. The session didn't even expire after 30 minutes. So I pushed further. I crafted a POC using curl admin dashboard. So he used his own cookie to get into admin dashboard. It worked, and this wasn't just a low prev account. I had copied the cookie from fished developer login earlier. Yes, OSINT helped me to get a test dev email that used the same credential on staging. So he just got a cookie from phishing and some OSINT. So he used those cookies, log in as a dev test user, capture the session cookie, log out, then use the same cookie as admin dashboard, access granted full PII disclosure. And yeah, that's how the bug goes. Then 82. From 404 page to $5K, how I changed forgotten bugs into critical exploit. Just let's click on to the free link. The first clue, an empty 404, that wasn't. It began with most would consider a dead end that looked something like admin target, port number 8443, and admin download. A blank page with 200 status code. Most scanners would mark this as nothing here and move on, but in security research, empty responses often hide the most interesting secrets. Uncovering the hidden file leader. After parameter testing, I discovered that admin target uses something like this js main.js. This returned the actual JavaScript file, confirming LFI, local file inclusion. And if you have LFI and if it's a Windows PC, you could try striking the goals such as webinf, webxml, webinf, and stuff like that. Admin incident respond. Then once you get these files, you get the logs. So the log contains these information. These are MD5 hashes. After cracking the MD5 hashes, this was the hash which the password looks something like this. You get full admin access. Then within the admin panel, there was a path which says admin faces export step to XHTML. That was the backdoor allowing server side code execution. You could run commands like id execute.txt. It gave you back the root access, and this was a really good bug. So I always say don't stop at 404s, do proper directory busting and understand the path. Initial path traversal was rated at 500, but when he changed that to RC, he was awarded $5,000. And yep, that was good. 83rd bug, the art of smart recon, how I found 10 plus vulnerabilities without firing a single exploit. The first bug, then only check the main domain. So what people do is that they check the main domain, they don't see another tool. So what you should do is mapping the hidden attack surface, the acquisition goldmine. Companies often forgot about systems from acquired businesses. Once I found legacy bot company still running WordPress that was unpatched, VPN old brand using outdated Pulse Secure VPN, reverse whois magic, then you do advanced subdomain discovery, then you do some way back URL discovery, then the GitHub rec configs, intelligent automation. Then what you start doing was that he got 100 valid vulnerabilities by using this particular thing. 43 critical security, $47,000 in total bounties, and there was an unprotected cloud monitoring old acquisition subdomain that gave me access to their entire AWS monitoring system. So what you should do is pick a target, spend 2-3 hours for pure recon, document everything in a spreadsheet, look for forgotten subdomains, exposed developer resources, historical vulnerabilities, and this method works for me a lot. I use a whole automation to map the entire surface attack surface area. So yep. Unearthing digital ghosts. How deleted GitHub files can make your bug bounty fortune. And yeah, I have covered it many times. Git files, if you find this particular thing, it's a gold mine. You can use githog truffle dogs to get the exposed keys. Won't be getting much deeper into that because I know it's like somewhat the same. I almost bought a 239 domain for $1, so it might be a business logic error where you do the price manipulation from 239. You just capture that request where you see 239, just put one and let it go. You, if you enable it through PayPal and pay for it, you might get a domain for $1, but you shouldn't do that. It's a classic example of uh, ris- parameter tampering. Unauthenticated password reset abuse. How this one works is, hello fellows researchers and security professionals. Today I would like to walk you through some serious vulnerability. How it worked was, user initiates a forgot password request by entering their email and solving a captcha. Upon submission, the original password is instantly removed from the user's account. A temporary password is generated and sent to their email address. This flow didn't verify if the request was legitimate. This means any unauthenticator attacker who knows the user's email address could trigger this process. So what you do is you fill in your email. As soon as you solve the captcha, click on reset password button. Your original password gets deleted and a temporary password gets there, right? So the affected functionality was located at this. So you enter this particular thing, you enter the email, you enter the code over here, and you could trigger that particular thing. Only an email address and captcha code was required, no further process testing. Navigate to the login page and click on forgot password, enter the victim email address, solve the captcha, intercept the request using burp suite, forward the request and capture the response. Attempt to log in with the original password, it will no longer work. This clearly shows the original password is removed upon the request. How this could be exploited further? What makes this issue even more dangerous is if you combine it with user enumeration and stored accesses, right? So you could get emails in bulk, wipe out data. So if you report it like that on a company, they would say it's intended, right? Because it's a feature. That's what the people said. Doesn't sound much big bug, but it's kind of abusing feature, so not bad. Stop giving explanation about everything, like no script kiddie reads about rate limit and like your target audience knows these. So yeah, I personally feel the same. It's no bug. The company would say it's an intended feature. But yeah, unlocking hidden vulnerabilities. So let's see what this one has for us. So the negative coupon exploit. A major e-commerce platform. The site allowed discount coupons like get apply, and this is the discount code which says summer 25 and amount 20. A hunter modified the amount parameter to give a negative value minus 1000. Instead of deducting $20, the system added $1000 to my cart balance. The backend blindly accepted the math. Total minus minus that turns to a plus 10,000. So it's he got a bounty for $10,000 as it's of critical severity for this bug, right? The unlimited SaaS free trial, the SaaS company with 7 days free trial. The trial check was client side. So if user trial end date is greater than date dot now, so if you change the trial end date till something that's not gonna end, you get free lifetime access without a payment. Got $7,500 for this bug. Then visible admin panel, a government portal with hidden admin panel. No, normal users couldn't see admin links, but the API still responded if you guessed endpoints. A simple change from user 1 to 3 to user 1 exposed all admin panel functions. It's an IDOR, highest criticality. So classic IDOR, as I just said, $15,000. So you could try doing these things like manipulating the amounts, trying with expiry dates, user IDs, and stuff like that. Try race conditions, false true, a lot of things. So yep, getting to the 88th, accessing admin directory. Back on the hunt. So again, you get the enumeration and logged in wayback URLs after fuzzing. You got something target like this sub.staging.target.com. Again, got to the wayback URLs. You got a path known as orders.json. This endpoint return JSON data that look like fake order records, probably test data. Issue on publicly accessible still servers, and so it doesn't involve public data. So they say as the reported issue pertains to a staging domain and doesn't involve, so it's not really a bug. People might have said that. um yep. GitHub. Why I have chosen these things, because a lot of you might come across these issues and you see that okay, these are the bugs but companies don't pay you, then we cuss those companies. That's not how it works. You should be able to understand the impact of that particular thing. So again, the git thing, you get a git config. You could try to get uh, a lot of credentials from .git.config because they have the env gold mine. Not going through that because there are already these ones covered. API, when an internal Swagger file opened the floodgates. How it works is that you get a swagger.index.html file like this. Swagger UI loaded a parade of golden ducks, but here's a catch: it wasn't your public basic public does. It was fully loaded internal routes. So you can try these endpoints like admin user delete transaction export users update role. Then you got this endpoint like users ID with a token over here, so you could get the date of any user, right? That's an IDOR. Then if you try changing the roles like body roles to admin, so you get a admin role with a normal cookie. That's not something good. So you could do a lot of mutations over these things. 91. Shodan have shown that how exposed device lead to the source code. This looks interesting. So mass recon is the as the key to success. Trust me, guys. So you got this domain like staging build pipe redacted. There was anonymous login enabled. It was inside a Jenkins without credentials. So he tried digging in more deeper. A few recent jobs got the I deploy production API, build UI container, push to GitHub. So if you don't know, Jenkins is for CI/CD pipeline. So I clicked on to push to GitHub. So there was GitHub username, GitHub password, GitHub repo, plain text credentials, right? Git clone the goodies. So if you have the ID, you have the password, you have the endpoint, so you could git clone the entire repository onto your thing. If you have the repo, you can get .env files. That env files has a lot secret information, then admin matrices, and everything's gone. To be honest, there's nothing else left if you have reached so far. So I personally believe if you have good enumeration, you are already a step ahead. So, how a late night I Spy today. So, I Spy today is a tool built for bug bounty hunters to catch the target. So, one night while aimlessly scrolling on the phone, a spy alert came in that there's a GitHub repository which contains a API key. So, once he got the API key, he reported to that particular target. And yeah, you could use this tool. I'm not sponsored by this tool, I Spy today, but you can check out if that helps you. You should try everything that you think might potentially help you. No captcha. So how I create mass registered. So it's like on the registration process, there's no captcha. You have this endpoint, you just keep changing the email using a list and intruder. There are no rate limit headers. So you could create 10,000 fake accounts, you could do referral abuse and everything by using these things. Most of the companies would claim it as a P5, P4, because they could easily fix it, and it has nothing like a financial impact and everything. So yeah, I don't know if he got a bounty for that or not. I guess not, because bugs like these are termed as, in their language, it's spamming or something like nuisance. But I hate those companies. How I turned CRS misconfig into full. CRS is cross origin resource sharing. So if you try these things and it says credential true, so it pretty much works a good way. So once you have confirmed that the credentials are true, so you spin up a malicious site demanding user data, hosted that over here, and to verify if the server is actually validating the origin, I ran this POC via burp. So it works like this: preview target.com myevil.site true, and if someone opens that, you get this particular data query: user profile name, email, SSTN, and with credential included but with a fake origin. So it's classic labs on Portuguese. You could try that. How to do CRS injection where access allow credentials are true, and you could potentially do a lot over here, right? Let's see on the next one. How I bypassed account verification with a simple host header trick. How this worked was that I started registering a new account with using victim's email. During this, I intercepted the sign up request and modified the host header to point to my own server. The backend accepted the request and built a verification link using my malicious host value. This link was then emailed to the victim as a part of the user verification. But if you have filled your own server, you might get that token too. When the victim clicked on the verification link, the token was sent to my server, not the original domain. So I could verify the account on behalf of the victim, and that's how you could do the email verification bypass. It was a bug, it's old, but it's worth it. Not so private paths, how public buckets build internal dashboards. Let's see into this. So the mass recon that started it all, recon, you while finding the recon, you got this particular bucket. When you try accessing this bucket, the ls listing without passwords are allowed, so you get dashboard config, json, api key, production envs. When you have the production envs, it has a lot of things inside that, so rest is history. So yeah, authentication bypass via email domain suffix manipulation. This could be good. How it works is that uh, what you do is, in the front end, I entered something like this: bishal at the rate redacted.com. Then I replaced the domain part via http request using burp suite. So then he front end, he entered something like redacted at the rate redacted.com, and at the back end he used bugcrowd ninja's id. Since it was checking email suffix only, like redacted.com and other internal domains, I checked my email, and to my surprise, it was successfully registered. Right. At first, there wasn't much to see the application field to submit an application, but after sending an application, I tried to modify it. Additionally, after submitting an application, it was supposed to be approved by admins, but if we could approve those applications ourselves, I was able to self-approve too. Moreover, via different API endpoints, I was able to leak all internal information using admins, because he was able to. It was relying on front end. So at the front end, he made the company believe that it belongs to that particular company, and then he changed this background email, and he was registered. Authentication bypass, that was authentication bypass. I could access my own application, however, using API endpoints. I was able to do CRUD. CRUD is create, read, update, and delete. So he has full privilege over the system. And yep, these things are by luck, to be honest, happens rarely. Desync or die trying, smuggling my way into internal APIs. Recon, you do the recon, and testing for desync attack. Now you use a very famous tool smuggler.py to test for desync attacks. If you don't know about desync, you should read about desync attacks, right? He used tested that against this endpoint, confirmed on a post endpoint. The front end proxy was handling requests differently from the back end. Now it was time to go manual. I crafted the CLTE payload and internal admin returned the information. It leaked internal only data like config keys and API tokens. Smuggling deeper. Once I knew the desync worked, I tested different payload styles cl.de, de.cl, te.te. The one that worked the best was this setup, where you send a blank request, zero get internal status to the local host. This gave me internal server status, IP, and even log requests. Then you start getting the configs. You can even get AWS secret access keys. So if you don't know about desync attacks, most probably I would be covering them in my another course for burp suit practitioner certification. You should see that, because it's not something for the beginners. We have already covered this bug. And the last one over here is exposed client secret in JavaScript. So JavaScripts are also gold mines, to be honest. So what actually happened was that when he was seeing the JavaScript files, there was a hard coded client secret right here. It was a hard coded client secret. When you interact with the client secret, you can get a lot of information, because client secrets are sometimes used for OAuth authentication and things like that. And if they are in plain text, you are always good, right? That's all for the course. It was a quick one, just to show you what things you could do in an environment. And yeah, that's all. Thank you. Hope you like the course.